Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Azharili, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you will come back to this study. Dear student, this second video lecture is the continuation of my first video lecture of week 4 for the course Applied Mathematics 1. In the first video lecture, we have already discussed the limits. Now in this second video lecture, we are going to learn about limits on trigonometric functions. In the first video lecture, we have already discussed that how to define the undefined 0 by 0 form for the algebraic functions. Now in this second video lecture today, we are going to learn about the undefined limits in case of trigonometric functions. When we obtain 0 by 0 form in case of trigonometric functions, we apply the theorem limit theta tends to 0 sine theta by theta is equal to 1. Dear students, in this theorem, the theta will be appear in the denominator and theta tends to 0, and this theta will be in radian Mayer. So when we obtain 0 by 0 form in case of trigonometric functions, we will use this theorem limit theta tends to 0 sine theta by theta which is equal to 1. We transform the function into this form, then we can easily put limit theta tends to 0 sine theta by theta is equal to 1. So by using this theorem, we can define the undefined 0 by 0 form for the limit of a function. Suppose you see over here a problem, limit y tends to 0 sine 3y divided by 4y. Dear students, if we put y equal to 0 in this function, we get indeterminate form, we get 0 by 0 form like you see over here. If we put y is equal to 0 sine 0 is equal to 0, and in the denominator y is equal to 0, we obtain 0. So this is 0 by 0 form. Now this is actually the undefined limit form. Now we are going to define this limit for the function sine theta sine 3y divided by 4y. So first of all, transform this function into the form of this theorem. For this theorem, you see over here the theta will be appear in the denominator. So theta is 3y, but in the denominator we obtain 4y, and the theta already tends to 0. So just we going to try to same these two terms, sine 3 theta 3y will be in the denominator. So multiplying this expression by 3, you see over here. Now 3 by 4 is the constant, and you see over here limits y tends to 0 sine 3y divided by 4y, multiplying and divided by 3. So 3 by 4 is equal to limit y tends to 0 sine 3y divided by 3y. You see over here, just change the position of these two numbers. You see over here 4 will be in this position and 3 will be in this position. So we obtain 3 by 4 limit y tends to 0 sine 3y divided by 3y. Now you see over here theta is appear in the denominator and theta tends to 0. Since y tends to 0, so 3y also tends to 0. Now we can applying this theorem like see over here, we can use this theorem. So this limit will be equal to 1, like you see over here. According to this formula, the limit y tends to 0 sine 3y divided by 3y is equal to 1. So 4 by 3 is 3 by 4 is it is, and putting this term is equal to 1, we obtain the result 3 by 4. Now another problem, to evaluate the limit x tends to 0 x square minus x plus sine x divided by 2x. So first of all, we can write this function as x square divided by 2x minus x divided by 2x plus sine x divided by 2x. Dear student, you see over here If we put the limit x into 0, we obtain the undefined limit like x0. This term will be 0 and sine 0 is equal to 0. So 0 divided by 0. So this is 0 by 0 form. Now we are going to try to define this limit. You see over here x, we can write x square divided by 2x, x divided by 2x, and sine x divided by 2x. Now x and x cancel. In the first term we obtain x by 2, and in the second term you see over here x and x cancel, we obtain 1 over 2, and in the last term you see over here sine x divided by x. So theta appear in the denominator and theta tends to 0, so we can easily applying the theorem on this term, limit x tends to 0 sine x divided by x. This term will be, according to the theorem, this term will be equal to 1. This term will be equal to 1. So now putting the limit x tends to 0, 0 by 2, 1 over 2 is the constant term, so we cannot applying the limit x is equal to 0 in this term. So minus 1 over 2 is it is, and this theorem is equal to 1. So 1 multiplied 1 over 2 is equal to 1 over 2. Now this 1 over 2 cancel with the minus 1 over 2, 0 by 2 obtain 0. So as a whole result we obtain 0. Now another problem, to evaluate the limit theta tends to 0 sine theta divided by sine 2 theta. If we applying the limit sine theta, theta is 0, so sine 0 0 and sine 0 again equal to 0. So this is 0 by 0 form. Now to define this undefined limit, we can we will transform this function into the theorem limit theta tends to 0 sine theta divided by theta. This theta will be appear in the denominator for this term and for this term. Now you see over here, if we put sine 2 theta is equal to 2 sine theta cos theta, this is the trigonometric identity. Sine 2 theta is equal to 2 sine theta cos theta. So sine theta divided by 2 sine theta cos theta, sine theta and sine theta cancel. So we obtain limit theta tends to 0, 1 over cos 2 theta. So without using theorem, by putting sine 2 theta is equal to 2 sine theta cos theta, we can define this undefined limit like you see over here. Sine theta is it is, and sine 2 theta is equal to 2 sine theta cos theta. So sine theta cancel, we obtain limit theta tends to 0, 1 over 2 cos theta. Now putting theta is equal to 0 in this term, we obtain cos 0 is equal to 1. So 1 multiplied 2, we obtain 2, and the result is equal to 1 over 2. Now another problem, to evaluate the limit theta tends to 0, 1 minus cos theta divided by theta. So you see over here, if we put theta is equal to 0 in this term, cos 0 is equal to 0, 1 minus 1 is equal to 0, and theta is equal to 0. So we obtain 0 by 0 form. Now to define this 0 by 0 form, first of all we multiply and divide, and multiplying this expression by the conjugate 1 plus cos 1 plus cos theta, 1 minus cos theta divided by theta, multiplying 1 plus cos theta divided by 1 plus cos theta. So dividing, multiplying this expression by the conjugate 1 plus cos theta, we obtain 1 minus cos theta divided by theta multiplied 1 plus cos theta divided by 1 plus cos theta. Now using the formula a minus b into a plus b, we obtain a square minus b square. So 1 represent a and cos theta represent b. 1 square equal to 1 and cos square theta, and multiplying these two terms in the denominator, theta into 1 plus cos theta. Now, dear students, according to trigonometric identity formula, we know that sine square theta plus cos square theta is equal to 1. So we obtain sine square theta is equal to 1 minus cos square theta. So putting in this expression 1 minus cos square theta is equal to sine square theta, we obtain limit theta tends to 0, sine square theta divided by theta into 1 plus cos theta. Now, by applying the theorem, we obtained limit theta tends to 0, sine theta divided by theta, sine square actually sine theta dot sine theta. So sine theta divided by sine theta divided by this theta, sine theta divided by this theta dot sine theta. Limit theta tends to 0, sine theta, and this term will be 1 over 1 plus cos theta, and for this term the limit is limit theta tends to 0. Now if we put the limit, this is a whole expression will be equal to 1 by using the theorem. This term will be equal to 1, and after putting the limit in this term, cos 0 is equal to 1. So this is actually, this term will be equal to 1 over 2, but this term is equal to 0 because the limit of theta is 0, theta value is 0, so sine 0 is equal to 0. So because of this term, as a whole result is equal to 0. You see over here the limit is 0. Now the next topic is the continuity of a function. A function f of x is continuous at x is equal to a if all of these conditions are satisfied. Number 1, f of a is defined. It means that a function value exists at x is equal to a. And number 2, limit x tends to a f of x exists. It means that a limit value exists as you approach x tends to a. In the third condition, the limit value and the function value will be equal. So these are three conditions for the continuity of a function. A function will be continuous if we put x is equal to a as a function value and f of a is defined, and if we put a limit value, then the limit value of the function will be exist and the limit value and the function value will be equal, then the function will be continuous. For example, you see here a problem, is this function f of x is equal to x plus 4 divided by x minus 3 is continuous at x is equal to 1 and at x is equal to 3. For both values of x, we must check each of the three conditions in the definition of continuity, like you see over here. If one of the condition is failed, the function will be discontinuous for that particular value of x. For example, we check the function continuity at x is equal to 1. So we put x is equal to 1. This is actually the function value. If the function value is exist, like you see over here, putting x is equal to 1 in this function, 1 plus 4 5, 1 minus 3 minus 2. So this is the 5 by 2. Now to check to see if a limit value exists. So we put this value as a limit x tends to 1, x plus 4 divided by x minus 3. So by using the law of limit for the quotient of two functions, applying the limit to the numerator and applying the limit to the denominator, we put the limit x is equal to 1 in the denominator, 1 plus 4 5 and 1 minus 3 is equal to minus 2. So now for the third condition, check that the function value equal to the limit value. So this is actually the functional value, this is the function value, and this is the limit value. So the function value and the limit value are equal. So condition number 3 is also satisfied. So the function is continuous at x is equal to 1. Now we check the function continuity at x is equal to 3. First of all, put this value as a function value. So 3 plus 4, this is the value of x in the function x plus 4. 3 plus 4 and 3 minus 3. You see over here in the given question we obtained the function x plus 4 and x minus 3, x plus 4 and x minus 3. Putting in this function x is equal to 3 plus 4, 3 minus 3. So you see over here 3 minus 3 is equal to 0, and any non-number 0 divided by 0 is undefined. So therefore the first condition of the continuity is failed. So the function is discontinuous at x is equal to 3. Now another problem, for what value of a this function f of x is equal to x square minus 1 x less than 3 and f of x is equal to 2x x greater than or equal to 3. This is actually the piecewise function. For the continuity of piecewise function we check two limits. One is called the left hand limit and other is called the right hand limit. The left hand limit mean x tends to minus 3. You see over here x tends to 3 minus. This is actually the x less than 3 mean this is the left hand limit. So for the left hand limit put the value in the piece of the function where x less than, represent x less than. X less than mean this is the piece of the function and we put left hand limit in this piece, and for the right hand limit we use the piece where x greater than. When x less than, this piece will be used for the left hand limit, and when x greater than, this piece will be used for the right hand limit, and x equal to will be used as a function value. So in this case the function value will be equal to the left hand limit and will be equal to the right hand limit. So left hand limit and right hand limit will be equal and the value will be equal to the function value. Then the function will be continuous in case of piecewise function. So dear students, you see over here in this function, so first of all we put the function value, the left hand value, the left hand limit in this piece. So limit x tends to 3 f of x, limit x tends to 3 x square minus 1. This is the left hand, this is the piece for the left hand limit. So putting x is equal to 3 square mean 9 minus 1 is equal to 8. Now for the right hand limit we use this piece 2ax. So limit x tends to 3 plus 3 mean right hand limit f of x. In both case we put x is equal to 3, but this plus sign and this minus sign only represent the direction for the limit, left hand limit and right hand limit. So putting x is equal to 3 in this piece for the right hand limit, limit x tends to 3 2ax. So x is equal to 3 mean 6a. Now since the function is continuous, in this question it is given that the function is continuous at every x. We want to find the value of a. Now since the function is continuous, by using the definition the left hand limit will be equal to the right hand limit. So this is the right hand limit and this is the left hand limit. So left hand limit is equal to right hand limit. This is the left hand limit and this is the right hand limit. Both limit are equal because it is given that the function is continuous. So 6a is equal to 8. Dividing both sides by 6 we obtain a is equal to 8 by 6, which is equal to 4 by 3. Now another problem, for what value of c this function is equal to cx minus 1 x less than or equal to 3 and cx square minus 1 x greater than or equal to 3. Now in this problem we want to find the value of c. So first of all put left hand limit. For the left hand limit x less than 3, this piece will be used. So putting x is equal to 3 and cx minus 1, x is equal to 3c minus 1. And for the right hand limit we use x greater than 3, we use this piece cx square. So limit x tends to 3 cx square minus 1. The value of x is 3, so 3 square 9c minus 1. Now it is given that the function is continuous, so the left hand limit will be equal to the right hand limit. This is the right hand limit and this is the left hand limit. 9c minus 1 is equal to 3c minus 1, which implies that 9c minus 3c minus 1 plus 1 is equal to 0. So 6 into c is equal to 0. Dividing both side by 6, we obtain c is equal to 0 by 6, which is equal to 0. So dear student, in this problem the value of c is 0. Now another problem, to discuss the continuity for this function f of x is equal to x minus 1 where x less than 3, and 2x plus 1 where x greater than or equal to 3 and x is equal to 3. So for the continuity of this function, first of all we use this function value. This is the function value. So x is equal to 3, put x is equal to 3 as a function value. We put x is equal to 3 as a function value in this piece. So f of 3 is equal to 2x plus 3. Putting the value of x is equal to 3, 2 multiplied 3 plus 1, 6 plus 1 is equal to 7. Now we use the two limit. One is the left hand limit and other is the right hand limit. For the left hand limit, x less than 3 mean we use this piece for the left hand limit. So limit x tends to 3, x minus 1, putting x is equal to 3 in this piece, 3 minus 1 is equal to 2. And for the right hand limit we use this piece, because x greater than mean we use this piece for the right hand limit. So x tends to 3, f of x is equal to x tends to 3, 2x plus 1. So putting x is equal to 3, 2 3 the 6 plus 1 is equal to 7. Now since in this problem you see over here the left hand limit value is 2 and the right hand limit value is 7. Left hand limit and right hand limit is not equal. You see over here these three values will be equal. The function value is equal to the left hand value is equal to the right hand value. So the function value is equal to the right hand value, but these two limits are not equal. Left hand limit and right hand limit are not equal. So this function is discontinuous at x is equal to 3. You see over here the right hand limit does not equal to the left hand limit. So the limit x tends to 3 of the function does not exist. It means that the function is discontinuous. Actually in this problem both the limit exist. Right hand limit is equal to 7 and left hand limit is equal to 7, and the function value is equal to 7. The function value is equal to the right hand limit, but these two limit are not equal. Right hand limit does not equal to left hand limit. So right hand limit does not equal to left hand limit, so the function is discontinuous at x is equal to 3. So dear students, the conclusion of this lecture is how to define the undefined limit for the trigonometric function. You see over here in this problem, you see over here the theorem limit theta tends to 0 sine theta by theta. The 0 by 0 form, undefined form for the trigonometric function will be defined by using this theorem you see over here in some problems. And another conclusion of this lecture is the continuity of the function. A function will be continuous if all these three conditions are equal. If all these three conditions exist, the function value of the function will be defined, and the limit value of the function will be exist, and the function value and the limit value will be equal. If these three conditions are satisfied, then the function will be continuous. If one of the condition is failed, then the function will be discontinuous. And you see over here some problems as example. And the continuity of piecewise function. For the continuity of piecewise function, the left hand limit and the right hand limit in the function value will be equal. Sometimes the right hand limit and left hand limit are not equal, then the function will be discontinuous. So these two points are the conclusion of this lectures. How to undefined 0 by 0 form for the trigonometric functions. We use the theorem sine theta tends to 0, sine theta by theta, which is equal to 1. And what is the continuous function, and what are the conditions for the continuity of the piecewise function. So this is the conclusion of this second video lecture for week number 4. Now this is the end of this segment. Thank you. Allah Hafiz.